a new question here. Find the forces of members CF, AD and AF. CF is this member, AD is here, and AF. So the first step would be again to get the reactional forces of the joints that we have. This is a hinge joint, so we replace it by two forces, HA, which is the horizontal force, and VA. The other one is a roller joint. So here the motion in x direction is allowed, but only the motion in vertical direction is blocked. So which is given by a reactional force. We take it as say RB, reactional force on point B. Now we will have to find these values. First, we will go for summation Fx equal to 0. We can see in this diagram, these two forces are vertically upwards. This force is acting vertically downwards. These two forces are also acting vertically downwards. So there are no forces to counter this HA in x direction. So we directly get HA is equal to 0. So one of our force is directly done. We have two unknown forces in positive y direction, and the other forces are downwards. Since we have two unknown forces, we cannot take summation of Fy directly because we will not be able to solve. So we take summation of moments at a point A and equate it to 0 because equilibrium condition is maintained. Now we take these forces. The first force is of 15 kilonewtons at a distance of 2.5 meters. So it is 50 into 2.5. But since this force will cause a moment in clockwise direction, we take it as negative. So we take minus 50. Then next would be a force F, which is of 100 newtons, and it will also cause a motion in anti-clockwise direction at a distance of 5 meters. The next is this force. This will again cause a motion in anti-clockwise direction, so this will also be negative, minus 150 kilo at a distance of 5 plus 2.5, that is 7.5 meters. And the last one, RB, which will cause a motion in anti-clockwise direction, so it will be positive RB, and the total distance will be into 10, and we equate this to 0. By using this entire equation, we get the value as of RB as 175 kilometers. Now we can directly apply summation Fy. So we continue here, summation Fy, and we equate it to 0. There are three forces in downward direction, so they will be negative, which is minus 50 kilonewtons, minus 100 kilonewtons, and minus 150 kilonewtons. And this RB is in positive direction. RB has a value of 175 kilonewton. And VA, which we have to find, which is the unknown, is also in positive direction, and we equate it to 0. And once we solve these values, we get VA is equal to 125 kilonewton. So now we have all the reactional forces with us. Now we'll shift our focus towards finding these values. Now an important point here, CF, AD and AF. CF is here, CF is here, this is AD, and this is AF. All these points, all these members rather, would be in this half of the system. So we'll, instead of going for joint to joint approach and finding the values, what we can do is we can take the section approach and make sure that we find all these three values in one go. I'll tell you how. We take a section in this portion and it will be something like this. So we have ensured that all our required members CF, AD and AF, all three are cut and we paste it here. So this is how it looks now. We have AC, we have AF, AD and FC which are required. Now we'll go ahead and solve this. Now we'll take this as an entire system and we will go about solving it by our normal equilibrium method, taking summation. Now we'll think this is a force in upward direction, this is a force in downward direction. We don't have any uh, known force in horizontal directions as of now. So we'll first take, we have one unknown here, this is also unknown and this is also unknown. So first what we'll do is we'll take the moment first about a point F. Now F is an extension of these forces here because here is our figure. We take a moment about this point and the first force that will be, this force will go through F, so it will be 0. This will be the first force which is F AD and it will be at a distance of 5 cos sine of 30 degrees. The next force would be, this is also passing through F, so it will be 0. This is the one. This will be, and AD would actually cause a moment in clockwise direction. So AD will also be negative. Now we have this force at point C, which is 50 kilonewtons. And this force is at a distance of 2.5 meters. So it is at 2.5 meters. And also we have a force at point A, and this will also be in clockwise direction, so this will also be negative 125 kilonewtons at a distance of 5 meters. When we apply this entire thing to the calculator, we get our force AD, which is required in the question as well, and the value is minus 200 meters. So this is the first force. In the same manner, now we have AD with us. So we just mark it. We have AD with us. There's only one force in horizontal direction which is unknown, and that is force FC. So that will be our next thing. We will go for vertical forces, summation of Fy equal to 0. Now, if 125 acting in upward direction, so this will be plus, minus 50 kilonewtons, these are in kilonewtons, acting in downward direction. Then FAD, we know FAD is minus 200, so we write it as, and it is in positive direction, so plus, minus 200, this is kilonewtons, minus 200 kilo at an angle of sine of 30 degrees. And now our unknown factor, which is again in downward direction, so this will be negative f of fc, making an angle of sine of 60 degrees. And when we solve these equations together, we get our unknown, which we have to find f cf or fc, f fc. Actually, we need to equate this to 0 first, and then we get f of fc, which is equal to minus 28.86 kilonewtons. This is the next force that we get. Now we have another force with us. This is force Fc. The only one remaining is AF, which is in horizontal direction. So we take some summation of Fx equated to 0. AF is unknown to us, so this will remain as FAF. We have two other forces which will have horizontal component. One is FAD, so this will be plus since it is in positive x direction. So plus FAD, making an angle of cos of 30 degrees. And the other is again FFC, it is again in positive x direction, so plus FFC and making an angle of a cos of 60 degrees, and we equate this to 0. And when we put in the values, we have FFC with us, we have FAD with us. So when we put in the values, we get FAF. We get FAF as 187.63 kilojoules. So this is the entire sum. Had we gone for the joint approach, we would have to solve this, and then entire sum would have been a two-page sum. And in exam, we don't have so much time because this sum would come for only for 10 marks. And the earlier sum that we saw was for 15 marks, and it was mentioned that we have to solve it for all the joints, not here. So we use this section approach intelligently so that we get all the three members in just one section. First we find the reactional forces, then taking moment about point F, and we find the first force, which is FAD, which is this one. Then we take summation of vertical forces, we find FFC, which is this one, and then summation of forces in horizontal direction, and we get FAF, which is this one. So this is an entire sum.